Okay, so here we're going to just derive the distance formula, which is pretty straightforward, but it's nice. It's a nice application of the Pythagorean theorem, and it's done in a very similar way as we derived the slope formula. What do we do? Well, in a lot of applications, and this becomes really useful when students understand that a lot of times we construct right triangles. This is very useful knowledge when they move on to trigonometry. So we create a right triangle here by coming straight down, perpendicular to the x-axis, straight across a horizontal line. That's going to create a right triangle, and we can use the Pythagorean theorem. We want to know this distance. Well, the x-coordinate for this point is x1. Put this up here. The x-coordinate for this point is x2, and this distance is this distance, x2, minus this, which is x1, leaves us with that. Similarly, the y-coordinate for this point is y2, the y-coordinate for this one is y1, this distance, which is y2, minus this, y1, leaves us with this. Now we use the Pythagorean theorem, the hypotenuse squared, which is d, equals x2 minus x1 squared, plus that distance, which is y2 minus y1 squared. Now we want to know what the distance is, not the distance squared, so we take the square root of both sides, and we get the square root of x2 minus x1 squared, plus y2 minus y1 squared. Now an observant student would say, why don't we do a plus or minus? Because we took the square root of a square. Well, you should. The reason we don't is because we're talking about distance, and distance we just don't normally talk about. Negative distances, I mean, I don't call my wife up on the way home from work and say, I'm -8 miles from home, I'll be home in -6 minutes. Yeah, we just don't talk about negative distance, and that's the reason why we only need to include the principal square root of the positive portion.